One set of concepts that explain it all.
I can guarantee you we'll create a crack in materialism with this.
So I was going to talk a little more, but let's bring David up here and allow you guys to ask me questions and David questions. And it can be questions about anything, not just about what I said. You want to ask me about, conscious computers or time and, whatever you want, whether we can go backwards and change things or how do we change reality, whatever, open to all of that.
What do you think about a possibility of reality surfing?
Reality surfing?
Yes.
Going from one reality to another?
Yes.
That whole concept of doing that, you're jumping from one reality to change this, to change that, it doesn't work that way. Mm-hmm. You're not really jumping from reality to reality. The whole idea of the many worlds, if you do it in terms of physical universes being generated that have, and what basically is said that everything that could possibly happen does happen, but it happens in some other universe and you can jump from one to the other. All right, well, if you're thinking in terms of physical universes all spawning off, that's really a silly idea, my opinion. That doesn't make sense. Now, if you think about all of that in probability, that's different. You think of it in terms of probability. I have this probable future database. That's all the things that could possibly happen in the future and the probability that they will. And that probable database, as things happen, the future becomes the present becomes the past, and I end up with a past database of everything that could have happened and the probability that it did. And then a little thin line that runs through that database is everything that actually did happen. Okay? So now that covers all the same ground, all the advantages of the many worlds, but I don't need to create, a quadrillion universes every microsecond. It's all done in probability. So you're not going to jump from one to the other, but what you can do is you can move from reality frame to reality frame, but it's not you playing in all the various reality frames, but there are multiple reality frames out there that you can go to and come back from. There's lots of virtual realities available in the larger conscious system that you can visit, but you're here to learn. You would like to project, say, what would happen if I'd done something else? What if I do this instead of that? Well, you can go into that database and look at the probabilities and do this and see where that leads and do that. And you can look at it as a movie. You can get graphs. You can get error bars on your graphs so that you can say, well, what if I'd married Susie instead of Jill? And I can go in there and I can look at, here we would have been, how many children we would have had, about, what would have gone on. And I can do that then with Jill. But I have to remember that's all just probability. That's not necessarily what's going to happen, because those probabilities change. Every time I make a choice, all the probabilities change. All right, I decide to marry Jill. Now all the probabilities change. Susie's, and her friends and her family and my family, they don't make friends anymore. We go our separate ways. Probabilities change. So the probability distribution is always in flux. And the key thing is you can modify those probabilities with your intent. That's how you change the future. You modify the probability of something happening. Doesn't mean it's going to change the way you want, because there may be an awful lot of probability you need to overcome. But you can at least change the probabilities of it. Your reality is sent to you in a data stream. In that data stream, you interpret the data based on what's also inside of you. You interpret that data, that's your reality. This guy goes into a coma, or gal goes into a coma. While he's in a coma, he gets a data stream. He's still conscious. And that data stream shows him another reality. Yes, that doesn't mean he hopped to another physical universe someplace. He's just in the data stream. Now, why did he get that particular reality? Probably was meaningful to him. There are probably choices and lessons in there for him that he needed to learn, things that were significant to him in his life and his choices. So he got that. Why? Because it would probably help him grow up, help him see a bigger picture. So that's why that's available. But that comes out of the probability. It doesn't necessarily have to have a physical universe in order for that to happen. It's just out of the probabilities. You can go in to the past database and you can say, what I'd like to see is back at such and such a time, and I don't want the most probable thing. I want the third most probable thing to happen, and it'll go through all of the network of possibilities, giving you the third most likely probable thing, and that's what you'll see happening. So you can go in there and watch the movie of your future.
I have a question about the experiment. Based on the results that you got, would you agree that the results show that it is the degree of measurability, not the observation and not the measurement, but the degree of measurability that determines the probability distribution?
I would say that what is important is the observability, which obviously is connected very strongly to the measurability. If the measurability is low, then the observability is going to be low, and so on. So those two are pretty well connected. The reason I say that is that this is a virtual reality, and all virtual realities exist only in the minds of the players. There is no place where elves and barbarians run around fighting each other. It only exists in the minds of the players. And if you want to put something in that virtual reality, you have to put something into the mind of a player, because that's where the virtual reality exists.
I guess what I'm asking is we know that it's not, we can take from the result of the experiment, that it's not the observation, it's not the measurement, it's the ability to be measured. Yeah,
I would say that it's the ability of someone to be able to see the results of that measurement. And I say that because that's the observer. If that information doesn't make it into the mind of an observer, a player, if there's no player that gets that information, then that information can't get into or be expressed in the virtual reality.
But in the results, the which way information is obscured, but you get a result that is a particle result. So there's no observation of the path, but you do see.
Right.
So that, but like I said, there was another experiment that I looked at with a silicon photonic chip where they had multiple pathways, and the degree to which they were able to tell which pathway it took, it would change the distribution at the end. So you would get somewhere in between a particle pattern and a interference pattern.
Right, you can do that if you get pieces of each. If you get some of the which way data and some not, then you'll get some of the particle pattern and some not.
It was the degree to which you could know what the path was.
Yes.
So, yeah.
Yeah, the degree to which you could know, and the word know to me is the degree to which you can observe. To me, the knowing and the observing are the same functions.
I'm not trying to put words in your mouth, but what you're saying is that the distribution is based on the knowability.
Yeah.
But you still require an observer at the end. But I mean, it's hard to get away from observing information. Otherwise, it's not information. So yeah,
exactly.
I get it. Thanks.
Yeah, exactly. Thanks. You have any comment on that, David?
In the end, you always need an observer to make an observer. Like if there's no consciousness, like who will report that the information was stored anywhere or there was an experiment being done? Like you need consciousness. You can get behind it.
Hi, Tom. I'm trying to connect one of the aspects in Indian mysticism to the world of MBT. So in Indian mysticism, the objective of a soul is to attain mukti. Mukti means salvation. So you go through the cycle of samsara, and your ultimate goal is to get out of this cycle and attain mukti or salvation. And it is very similar to what is depicted in the Groundhog Day, where he goes through the cycle over and over again until he evolves and get out of that cycle. So what is a similar concept in MBT? Is there a concept that explains the same theme?
It's a little different. That's one of the places that we probably differ, and that is that in MBT, the point is to become love, and that's similar to to your viewpoint too. To become love, to become caring, to become helpful, all those sorts of things. Give up fear, give up ego, and that mission really never ends. It's not like you get to a point where, okay, you've obtained the realization, you're aware of all of that, you have given up, you've given up fear. I see that in terms of lowering entropy. So yes, you can lower entropy as you go, but you get to the point where if you quit, if you stop working on it, if you stop putting energy into evolving and doing the right thing, you start to de-evolve. It's the nature of entropy. If you don't put energy in to maintain it, it will start to disappear. So in that case, there is no end. It's not that you get to a point and you reach this and now after that, you don't have to be kind anymore. You can be rude, you can do whatever you want, and it doesn't matter because you've made it. It's not that way. You have to keep, as a piece of consciousness, you have to keep interacting. You have to keep connecting with others. You just don't go off and disappear. Now, I think, at least in some of the Buddhist circles, the idea is not only to get out of the circle, but then to merge with the Godhead. Yeah. Yep. Well, that is really not helpful, because what happened was that the Godhead, the larger conscious system, in my view, it split off pieces of itself because that was more effective for it to evolve with the many pieces. The pieces start coming back and re-merging, it's going to end up eventually back in the same place it was, limited as one monolithic thing. So there's advantages to stay. So in my, I hate to say the word, in my theology, the idea is you never get to the end. Evolution is open-ended. Evolution doesn't get to a point and say, all right, we've made it, let's quit. All the individuals are all perfect now. We're done. What happens is that there's always new coming in at the bottom. There's always room to help. There's more virtual realities going on than just this one. There's always some place to help, always some place where you can be of service, where you can help other people grow up. And you need to keep working on it, or you'll start to backslide. It's not an attainment that you get like a certification. Oh, I'm certificate, I have this certificate that I'm perfect. That doesn't work. You show perfection in your understanding and in the love that you can spread and share with others. That's how you show perfection, not by showing your certificate. So in my theology, you just keep working and you get to serve at a higher level of interaction. So in the beginning, you're mostly working on yourself, getting rid of your fear, getting rid of your ego. You eventually get some success at that, and now you start helping others. And you get more success at that, and now you're a teacher. And you get more success at that, you come and you're a teacher of, thousands, not just tens. So you keep coming back because you want to, not because you have to. And I know I run into people and they say, this is my last incarnation. I'm getting out of this hellhole. I'm gone after this one. Well, what does that sound like to me is ego. That's a bunch of ego. Because if you had actually grown up, you'd say, oh, I can't wait to my next incarnation because I think I can be even more helpful than I was, than I am now, because I've learned so much, so I can be more helpful. So if you've really grown up, you want to help. You want to be part of the solution. You want to make it easier for others to grow up. Even if all you do is work in a soup kitchen and help feed people, that's worthy. So you come back to help. And you never get to the point where you're beyond being helpful, because being helpful is what it's all about. That's the growing up. And to return to the Godhead, well, that's kind of moving in the opposite direction. What the Godhead needs is for you to get back down there and start helping. Help other people grow. Be a source of light for others. Give encouragement to others. So that's what it's all about. So you never run out of that. And you don't have to get to an end because evolution's open-ended. It just keeps going on and on and on. As we evolve, we change. As we change, you get a whole new set of possibilities, a whole new set of problems, a whole new set of things to do as people grow. So that's kind of where mine is. So I guess that's one place. Mostly Buddhism and Hinduism and MBT, we're just sort of like that. We go along really, really closely together in the way we see the world and what's important and what's not. Very, very closely. But that's one place where we separate. I don't see an end. I see that when you get to where you have gotten rid of your fear, you're just a more valuable asset. And you need to get to work and be helpful as you can, because it's not a whole lot of people that get to that point. So we need as many of them as we can get to get there to help out. It's not an easy place to get to. So then what you become is you become a lot like the larger consciousness system. When you grow up, you're a piece of grown-up consciousness. The larger conscious system is a grown-up consciousness. You're sort of like the larger consciousness system. You're just smaller. You're a subset. But you have to keep working at it to stay that way.
Thank you, Tom. There is this concept of either you don't have a higher existence per se, like an evolved being. Either you become an assistant to the Godhead or you merge with the Godhead.
Yeah.
Either way, you are serving the purpose of the Godhead.
Yeah.
Thank you.
Mm-hmm.
Hi, Tom. Big fan of your work and your dance moves. This event's called Doorway to the Future, and David's working on a sci-fi potential movie. I was curious to know, once reality hits that point here, all the avatars realize we live in a virtual reality. We accept your theology as virtual idealism. What do you see a potential plot for that sci-fi movie he's looking to build? What could our future look like?
Well, it's going to be a lot nicer and more pleasant than it is now. If we get rid of materialism, we get rid of that ethic that says grab whatever you can grab and try to keep it, and take it away from others if you can. Other people are just resources out there for you to use. If we get rid of those attitudes, then automatically all of our institutions will change. Our corporate attitudes, our government attitudes, our legal attitudes, all of that is going to change dramatically because we will value life, we'll value individuals. All of the narrow-mindedness that we have and our fear of those that are different than us will all go away. Well, I won't say it all goes away. It'll never all go away, but it'll diminish to the point that it's a small enough minority that it doesn't really perturbate the whole very much. So we won't care. Yes, there's always going to be some amount that's not going to cooperate with that. We'll always have to deal with that. But if that's small, it doesn't really matter too much. So I think it'll be a kinder, gentler place where society will take care of people, where they all realize that there's plenty enough to go around. And institutions will change, attitudes will change, and eventually we might even get to the vision that Bob Monroe had. And he had in one of his books, he said, well, I went to, I think it was something like It wasn't in the 2000s. I think it was in the 3000s, 3038 or some kind of thing like that. And he found a place that was pristine and beautiful. Nature was abundant. People were not. They had moved on, some other reality, some other place. Now, whether that's the case or not, I wouldn't know. I don't know why people would move on. People will grow. But the whole point of growing up is to be helpful to people. So why would the people all disperse and go someplace else? Where life works well, there should be abundance, and abundance of people as well as abundance of everything else. So I would think you would have societies and cities, and it would be a very busy place, perfectly aware of the carrying capacity of the earth and not to exceed that. It would be a place where you were rewarded according to your contribution. It would be a place where there was more personal freedom than ever before. There wouldn't be the treadmill that you get on. You could be a brain surgeon on Tuesdays and Thursdays and ride on the back of a garbage truck Mondays, Wednesdays, and Fridays just because you get the fresh air and you get to work out and you stay healthy that way rather than constantly, doing brain surgery that doesn't use your muscles. I'd say it would be a free place. And anybody who can contribute is welcome. And you can contribute by being a poet, by being, somebody who picks paper up off the ground, by being a doctor, a lawyer, an Indian chief, a leader, whatever, an inventor. I would think technology would grow more quickly, even. Computer, you wouldn't have all that downside to the internet that you have now. Just a lot of things would change, but I kind of disagree with Bob's vision in the sense there weren't any more people unless they all, incarnated at other virtual reality systems because they were at the point that they could be very helpful. But I kind of doubt that. Where you learn is in relationship. That's where you learn to give up your ego, is in a relationship. And the deeper the relationship, the more you're going to learn. You can go to the office and have nice conversations with people at the office, but always stay shallow so you can still work with them. You don't get into fights or get upset with them. But with that significant other, that's where the rubber meets the road in relationships. That's where we are stressed to get rid of our ego. So I would say it would be a place where there were a lot of relationships and a lot of people. Not only, it's the same thing that I said before. If you stop working on it, you start backsliding. It's the nature of entropy. Entropy says that you can lower entropy, but you have to put energy in. If you don't put any energy in, the entropy just starts to increase. And you start to grow a little bit more ego, being a little more, full of yourself. And pretty soon you would have backslid down and need to do some more work. So that's the kind of thing I would have. Now, how do you make a movie that gets all that and makes it
some spice?
Yeah, makes it. You got for a successul movie.
We got to go viral.
It needs to have violence. It needs to have sex. It needs to have some cute people in it. That's what sells in the movie theater. But it has to have a nice. This movie. I agree with you. This movie can't be like that. If it's all that, then
I want your take.
It's just like the other movies. Mm-hmm. This needs to be something that is uplifting, that you come out of it with an idea, I'd like to live there. That's really a great place. But you have to make it with enough drama and enough excitement to keep people interested. Mm-hmm. Yeah.
Thank you, Tom.
Mm-hmm.
Hi, Tom. Do you see a way to crash the simulation, the rendering engine?
No, I don't think that's possible. And the reason why that's not possible is the larger conscious system is conscious. It's not just a computer that's not conscious. it will know what you're planning, what you're doing, and why you're doing it, and all that will be clear to it long before you ever get to pull your plan together. So I don't think that's going to work very well, and it will already have the antidote prepared when you drop that bomb. So I don't think that's going to work because it's so efficient doing things that are probabilistic. Instead of calculating huge calculations, you're just pulling random draws, and that's so efficient that I don't think there's any situation that's going to be like a denial of service. You know, you're going to overrun it. I don't think that's going to be the thing. And we already discovered that when you back it into a corner, it figures a way out. You know, it says, all right, from now on, particles, one at a time, will be treated like waves. And you know what that did for us? Not only did it have an interference pattern with single particles, like how'd that happen? How did the particles find their way over to do that? But now particles have all the properties that waves have. Do you see that, those 0 degrees, 90 degrees polarizers that were there? Well, what does it mean to have a polarized particle? What the hell is a polarized particle? Particles don't get polarized. Waves get polarized. Waves, electromagnetic things, they go this way, or they could go that way. Polarized. A particle, you know, this microphone is polarized. You take a particle, run it through those polarizers, it works just like a wave. And there's no reason for that at all. It's totally irrational. But it does, because the LCS had to use that concept to solve the problem of not having a logical conflict between optics and quantum optics. So also, you send a particle into a lens, and guess what? It gets bent, just like light. It has a frequency, you know, the frequency of a baseball. A polarized baseball, you know, polarized particles that bend in lenses and so on are not particularly rational in our normal way of thinking of things being rational. But in a virtual reality, the rendering engine can do whatever it pleases. And it got stuck. You know, you think, can you get it stuck between a rock and a hard place? Well, that double slit experiment was one thing that got it stuck between a rock and a hard place. And what it did was created a whole new thing about how we see particles. Particles now have all the same stuff that waves had just because of that. So we have that. Now, we do have one where we're trying to create we call that a miracle, right? Minor miracle. These particles all rearrange themselves on the screen in an interference pattern, which violates, Newton's idea about traveling in a straight line. But we have one of the experiments we're going to do, and it won't be the first one. This is a hard one. It's going to take a couple of iterations to get there. But here's what will happen in the end. You will have an experiment where the researcher will be able to tell ahead of time how a radioactive substance will shoot off particles. That's the radiation. We used to think of it as they shot off waves, but now everything's particles. So it shoots off particles, and those particles have to come off in just a random way. And we'll have a system where we'll have a radioactive source, a Geiger counter in a hemisphere, another Geiger counter in a hemisphere next to it, and the particle will be in the middle. So any particle that comes off will have to go through this Geiger counter or that one, like a 1 or a 0, one or the other. And the experimenter will be able to say, the next particle that flies off that nucleus is going to come through that Geiger counter. And the one after that will also come through that Geiger counter. And the one after that will go through the other Geiger counter. They will be able to predict the direction that that particle comes off. At least that's the point of the experiment. Well, that's going to put the larger consciousness between a rock and a hard place again. And it's based on the information that the experimenter knows. And what that's going to say is that if your experimenter knows certain things, the reality has to reconfigure itself to respond to that. That tells me two things. One, this is a virtual reality because no other reality can reconfigure itself to do what it pleases as far as particle going this way or that way. And secondly, it says that it has to do with consciousness because this is a consciousness responding to a problem. And as that problem changes, if that person doesn't have that information, it does this, and if they do have that information, it does something else. Well, that requires thought. That's a choice. So it's saying that the larger system is both conscious, okay, and that this is a virtual reality. So it has those two components to it. Now, the standard physics answer is going to be some kind of magic entanglement because entanglement solves all problems. Everything's connected to everything else. Information can't be destroyed. It flows everywhere. And that will be an answer that will solve the problem as well. That entanglement, everything's entangled with everything else, is almost the physicist's equivalent to God does it. You know, on the religious side, ask him any kind of question you want, and the answer is, God does it. But it's not really a helpful answer. And the physicists now have figured out something that's just as good. It's entanglement.
Tom, how does the ordinary person become like you? Is it a realistic goal? By that I mean, how do we become experts at exploring the larger consciousness system and have downloads of wisdom on demand? How do we become best friends with the big cheese? Or is it only possible if we quit our jobs and make it a full-time occupation? And even then, is it extremely unlikely that we will be of a high enough quality of consciousness? Why didn't the immersive training sessions work in the way Bob had hoped?
Okay.
Thank you.
Yeah. There's a lot of questions all packed up together. I would say that Bob's work really is working. It hasn't done, it hasn't reached that many people. We've got 9 billion people here, and even if you're talking to, tens of millions, that's a small fraction of 9 billion. So it takes a while doing that. But it's not about, getting data. It's not about connecting with the big J's. It's not about anything paranormal. Paranormal can be a tool to help people learn. But what has to happen is that people have to grow up. They have to let go of their fear. That's the main thing. If you never do anything paranormal ever, that won't stop you from growing up and becoming, love. You don't have to do paranormal things to do that. Now, I started on this path doing paranormal things. It was with Bob Monroe, and I started this as a 20-something-year-old physicist who was very left-brained at that time, atheist at that time, thought I knew everything, arrogant, all that stuff. But what I learned, doing the paranormal, the reason the paranormal can be a tool is that once you start seeing the bigger picture and yourself getting smaller and smaller and smaller in relation to that bigger picture, and once you realize that the point of things isn't you, it's other, and that helps if you have a big picture. If you have a tiny picture, then you tend to be at the center of the universe and there's everything else out there. As you get a bigger picture, you find out that just isn't true. So the paranormal can help people grow up. It helped me, gave me bigger pictures. Now, I had had experiences before I ever met Bob Monroe. I was already primed for this. But I think that's true in general. People get involved in doing paranormal things. Pretty soon they say, oh, I can heal, I can remote view. And it takes a while for that to work into their psyche, and they start seeing a bigger reality. and realize that they have choices. Well, what are you going to do with that? You're going to remote view the girls' locker room? What are you going to do with that skill? So you grow up some. You say, yes, I've got choices in the world, ethical choices, moral choices, and I need to take those seriously. Because you'll also find out if you don't take them seriously, your skill level either stops growing or starts to degrade. You start losing it. And as you grow up and get rid of your fear, you just get better and better. It gets easier and easier. So the paranormal is one path, and that's a slow path, right? I got into that in my late 20s, middle to late 20s, and here I am almost 80. Yeah, still kicking after all these years, but it's been a long time. It's not a quick process. But if there's just enough of us, maybe not even 10%, if there were just enough of us, well, 10% of 9 billion is almost a billion people, right? 10% of 10 billion would be a billion people. So it's almost a billion people. If we could get that kind of numbers who were kinder, gentler, had bigger pictures, all the rest would follow. Because those people would set an example. Their lives would be great. They would be happy, they would be smiling, they would be giving, they would be liked, they'd be looked up to. They would be like the perfect people. I want to be like that example. And it would grow, and it would grow quickly. Now, the masses of people would take some time. But it doesn't take, we don't have to get 9 billion people to become gurus. We just need enough people to grow up that it spreads. And it will spread because there's a thing called collective consciousness. And if you are grown up, you help the people around you grow up. If you're really not grown up and you're really, really self-centered, you drag down all the people around you. Make it harder for them to grow up, easier for them to become more self-centered. So this collective consciousness thing builds, and we just need to build enough of it that we can influence the rest to come along in time. So for that reason, I want to go mainstream, get into the mainstream. Now, Buddha and I share a lot of the same ideas. They just said, those ideas have been around for many centuries, but Buddha's still in the margins. He's not in the mainstream. Millions and millions of followers, but still in the margins, not mainstream. Beanie Babies got in the mainstream. So did hula hoops, but the Buddha didn't make it. So, how do you get into the mainstream? Well, the only way I know of to get in the mainstream, there's two ways. One is the quick way. The quick way still takes a long time, but the quick way is to get the scientists to tell everybody else that what you're doing is true, that this is a virtual reality. Love is the answer. If you get the scientists to say that, the scientists are the high priests now. They're the ones that tell everybody else what to believe. If they say that, they won't mean to start a landslide, but it'll start one anyway. And that will pull the rug up out from under the basement for a lot of people, and they'll be looking for something else. And we may have a little rough period there, but there's a good possibility that attitude in the mainstream will get people thinking that they should be more kind. They should care more about others, that it's important. And as that spreads, this will work. So that's the quick way, is to have science validate the truth of what you say. It's the only way to get into the mainstream. The other way may take millennia. That's just waiting one at a time for people to grow up and change. And we just do the best we can to grow up and help others grow up some of them will help others to grow up, and that may take a long, long time, but it will get there. I can guarantee you that we will get to this kinder, gentler place I'm telling you about. We will get there, because that is where evolution is taking us. And evolution may be very, very slow, but it's also relentless. It just keeps chugging on no matter how backward we get. We may backslide and end up in a worse place than we were, but the evolution will just keep chugging, and eventually we will make it. So it's a matter of how long do we wait? Well, I'd like my grandchildren to grow up in that sweeter, kinder place. That would be nice. That's a place where people find fulfillment in doing what their heart tells them to do. You're not on this material track of how do you make money and keep it. You're on a track of how do I express my caring and love. There's thousands of ways to express that. And you can do and be almost anything you want to do and be, as long as it contributes to the overall society. And you can change what you're doing on a dime if you like. And when you decide that I want to stop doing brain surgery and do garbage trucks instead, the system will adjust to that. Find somebody else to do your brain surgery on Mondays, Wednesdays, and Fridays or whatever, and find you something to do. The system will adjust because you're a member of it and you're valued, and everybody in the society wants you to be successful and feel happy just because they care. So it's hard to imagine. I mean, from where we come from, that's a hard place to imagine, but that's the way it would work. So the personal freedom would be great. You know, some people I've talked to, they go, oh, that sounds like a collective nightmare, you know, where some big boss somewhere tells everybody what to do and everybody has to do it. No, it would be just the opposite. It would maximize personal freedom. Maximize it, because that's what the system would be about. The success of individuals, not the success of corporations. So it's coming, but I agree with you, not fast enough.
Thank you so much, Martin.
Yeah.
Tom, I heard you drop a sentence that seemed rather significant, which was that the experiment that was done wasn't your experiment. What would your experiment have been, and how did it differ to what happened, and why is what happened not your experiment?
Okay, what you want to see is these other slides that I never got to. This is what I originally had in mind. Okay, you'll notice that D1, D2, the two detectors that are right at the bottom of the slits, are on. I don't know if you can see that. I guess you can. It showed up pretty well. They're on. The two recorders that record that which way information are off. Okay. Now, in this case, no which way data would be recorded, though it would be detected. So it's detected but not recorded. That was the experiment. So let's set that up. Let's collect that which way data, but let's not record it. And then there will be no which way data for an observer to observe. And let's see what happens. And my idea was we'd see an interference pattern. Well, when we started with that experiment, we were told that we can't do that, because in the real world, getting which way data is just not that easy. You can't just say, oh, here's the which way data. You know, it just falls off the bottom of the slit into that little detector. In order to get the which way data, you have to do things that really interfere with the experiment itself. So in order to go out and touch that photon or that electron, you have to, when you touch it, you affect it, you change it. So now you've changed the experiment. It's not just a particle, it's a particle that you've done something to it. You've added something to the experiment. Okay, so they said that's impossible. if you can't get which-way data that's clean like this. Now, I wasn't doing experimental physics when I drew these pictures. I was strictly theoretical. Theoretical, this makes good sense, and I think it would go that way. But if you're experimentalist, you look at that and say, no way. So one of the things David and I are looking at is a way to do that that's touchless. David dug up some, to me, obscure paper that showed that there was a way to measure something without ever touching it, without even looking at it, not having any interaction with it any way at all. And maybe we could use that methodology to collect which-way data. Okay, and if we could, then maybe we can do this experiment. But I think that would be extremely hard and extremely difficult, but we're going to find that out. That's one of the things that we want to study and see how hard and how difficult is it going to be. Is that possible? All right, so we don't know whether that's possible or not. So when we found out that we couldn't do this experiment because experimentally it just couldn't be done, there's no way to collect that which-way data without interfering with the experiment. So we decided to do something else, and we needed to do some quantum physics in order to build up. Part of the purpose here was to build up a reputation in CUSAC for an organization that could do these kinds of things. So that the second iteration, we wouldn't have all the physicists turning us down because they saw the consciousness word somewhere in our paper. They'd see us as serious researchers who were actually doing real physics. So in any case, if we can do this thing with Dave, that David came up with, that will maybe work. And when we talk to some other physicists, David's talked to other physicists. David hangs out with physicists, and maybe his landlord's a physicist, I don't know, but he hangs out with physicists all the time. So he's talking to these guys, and they're mostly top end people. These aren't just graduate students who really don't know what they're doing. These are people who have good connections and know what they're doing. They looked at that experiment that I told you about with the two detectors, the particle, which way the emitted particle would go, and they looked at it and said, oh, that should work. So that's encouraging. They didn't see anything that said, no, you can't do that. They said this will work. So we're still interested in doing that one, but that's, again, going to be expensive and a long time, and all that turns out to be money. If you got a little bit of money, you can do one experiment and it might take you 3 or 4 years to get it done. If you got 10 times that much money, you can do 5 or 6 experiments at the same time, and then they'll all get done in a couple of years, and you'll learn a whole lot more. So it depends a lot on the resources that we have. We have enough resources right now to limp on and do an experiment, maybe even 2. I like doing 2 because if you do 1, no matter what you get, if it's interesting, everybody else will say, well, they made a mistake. It's not right. And then they'll walk away from it. If you have 2 of them, and they are both independent, and they both get the same results, then you've got a lot more logic on your side. It wasn't a mistake. This is the way it turns out. And the 2 can corroborate with each other and help each other get over problems that one finds can help the others. And we did that with this. There was some crosstalk going on between the 2 teams that were doing this. So enough money to limp on with something small, but David thinks big. You heard that, from major cinematic extravaganzas, to 5 or 6 different experiments. One of the things we're going to do is try to get other physicists not only to take us seriously, but to think about the problem. So it's not just David and I trying to figure out what to do. We want to enroll another 100 physicists to be thinking about how to solve this problem. And that's the thing we want to do with prize money. Put up prize money. The people can help us solve this problem, and we'll have to write the problem out, of course, in very good detail. But if anybody can help us solve this problem, then you win the prize. So, and we hopefully will put, a minimum of like $20,000 as a prize. The last prize that actually was real significant was like $40,000 prize. That'd be a little rich for us, but it'd be nice if you could give them a $50,000 prize. It was just, the bigger the prize is, the more attention you're going to get focused on the problem, obviously. So again, that has to do with money. So we want to enlist other people to help us. All right, so let's see, where are we now?
What is this non-interactive detection method that you want to use?
David will tell you.
Thanks. Okay, good. I came prepared. Okay. So I have to explain another. This is called the Elitzer-Weidman interaction-free measurement. So this setup is called Mach-Zehnder interferometer. I can say it. Interferometer. I can say it. Forget about it. So. Thanks. I won't try to say it again. So we send single photons to a beam splitter, and this experiment is equivalent mathematically to the double slit, okay? In the sense that we send single photons to a beam splitter. The beam splitter splits the path of the photon into two possible paths. So the photon has 50% chance of going this way and 50% chance of going this way, like taking slit A or slit B. So we have two paths, and then here we have another beam splitter, so it recombines the photon. So if the photon went this path, then at this beam splitter it can either continue or be reflected. And same for this one. Here it can continue or be reflected. So this means that at D1, we don't know, when it clicks at D1, we don't know by which path the photon went. It could have went from this way here or this path here. And since we don't know the which way data, what we see here, it's a circular interference pattern. We get a circular interference pattern with the bright spot in the middle. And on D2, same thing. We don't know by which by which path it went. So it can be this way or this way. Since we don't know the which way data, we get again an interference pattern, but it's the complementary interference pattern, where we have a dark spot in the middle. So if the experiment was perfect, without any noise, it will be pure dark at the center and pure light in the middle. Okay, so the 100% here and 0%, I'm talking about the middle of that pattern. Okay, so just follow me, I'll just talk about the middle. So this means that if we just have a detector in the middle, we will only get clicks at D1, because light only reach D1 here, and we'll never get any click at the center of D2 because it's a dark spot here. So the point, if you follow me, is that if we run this experiment and we send photon one at a time in a perfect setup, we only get clicks at D1 and no clicks at D2 because of the interference. So now comes the interaction-free measurement, which is really crazy weird. So I'll move here. Sorry, 4 people there. Okay, so now we are adding here an object. Could be anything. Could be a baseball, a card. I could put my hand, whatever. Don't put your hand in front of a laser, by the way. But if I put an object here, what happens? So let's say I send 100 photons. Before I would get 100 clicks here, 0 click up there. If I send now 100 photon, so 1 photon at a time, so the photon comes here. It can be transmitted. If it's transmitted, like 50% will be transmitted, it will touch the object. So the photon will touch the object and be absorbed by the object. So it will not continue. So 50% of the photon will be absorbed by the object. But the other 50% will go up and then reach this this beam splitter. And this time, it will be either transmitted or reflected 50-50. But since we don't have a photon in the other path, this time, we'll get 50% there, 50% there. And in this case, we know the which way information. It came from here. So this time we don't have interference anymore. We have a blob, like a particle pattern. So if we would have like 100 photons, I would get 50 photons here, 25 here, 25 here. Following me? So here's the mystery. If we get a click here, just one detection, see if I just get one single photon here, it means that there's a photon that did this path, like that, like that, like that, and it click, so I have a click. But here's the crazy thing. If there's no object, like here, if there's no object, I never get a click here, never. So I add an object right here. And no photon ever touches it. Nothing ever touches that object. And I click here, and I can know there's an object here. So I can, having a click here, allows me to determine there's an object here when nothing ever touches that thing. So this is called interaction-free measurement. It was proposed by Eliezer Wyman, which are two people. They did it in the lab, and it works. They even invented cameras where you can put, it's not like, it's in a lab, but you can put like a cat here, like a statue of a cat or something like that, and you can identify the shape of the cat without ever touching it. So this is called an interaction-free measurement. So I haven't drawn it, but the idea is that if we do a double slit experiment with, let's say, electrons that goes at each slit, and let's say we build a system like that, and we put it as a detector at each slit. So when the electrons go through slit A, the electron would be that thing. So the electron that gets out of slit A would be that thing. So with a separate photon, we could know there was an electron here without ever touching it. So this would be a way to implement a detector at slit A or B that never touch or interact or become entangled with the electrons going through the slits. The issue is that doing this will probably cost like $5 to $10 million in a lot of time. And the other issue is that scientists, when I talked to that with scientists, physicists, they told me, oh, but you know, David, just the fact that the photon could have touched the object here is enough to collapse. It's enough to break the coherent information of quantum. Like they say, well, this is what they told me. Even if it clicks here and never touched it, the fact that it could have touched it will entangle this whole setup with the object here. But it's weird. So this means that if we build something, let's say around me, I'm here, okay, I don't know, and we build this system around me, and they send a photon that never touches me, I become entangled with the thing that they built around me that I never seen or touch. So it's really, really weird. I don't know what to think about it. I mean, this is what the math says, but it's really confusing. So, yeah, that's my answer. Like, I'm just explaining the theory. I don't have an opinion outside of that, but that's interaction-free measurement. It's pretty weird.
Even if that was successful, would it upend any orthodoxy that's already out there, any of the formalism, or?
Oh yeah, if it's successful that we can detect which way data with interaction-free measurement and conserve the interference pattern, I mean, it's Nobel Prize worthy, it changed the world and blah, blah, blah. And by the way, that's why physicists are so super critical. They're like, it's too fancy, it won't work, follow the math, because it implies new physics. But this is what we are here for, so that's my answer.
May I ask a question? Following the MBT theory, the object itself is consciousness, right? Part of the mind of God. So it would know, it would detect itself. Just like any detector is part of the system. So not recording it maybe doesn't allow us to see it, but it's still part of the system detecting it.
Yes, everything's part of the system.
Yeah.
System knows all. This is a virtual reality, and the rendering engine has not only rendering what's happening right now, but it's been rendering everything that's happened here, from the beginning. So it basically knows everything there is to know.
Because it knows the which way data, it's going to collapse.
Well, it may not be that the system knows. Maybe what's important is that the experimenter knows. The experimenter's in the virtual reality. That information comes into the virtual reality such that it's available to an experimenter. Whether he reads it or not is irrelevant. It's that it's just available in the virtual reality. Then that brings that information into the system, and now it's part of the virtual reality. It's like that. So that's kind of what the argument is here. Does it take a conscious observer to have the information available to him? And that makes all the difference, because that puts it in this reality. Otherwise, if it's not in this reality, then it's, nothing happens. It's not in the reality.
Could the conscious observer be consciousness itself?
I don't think so. In a virtual reality, let's say they're talking about the World of Warcraft or something, and you want to plant a tree in the World of Warcraft where there's no tree now. Well, the way you do that is put a tree in the data stream of some client that's serving, that you're serving World of Warcraft to. And then anybody who looks at that spot, you'll put a tree in their data stream as well, so it shows up on their computer. So that puts it in the reality. Now that tree is a part of that reality, and anybody who looks there will see it. But if it's just that the system, says, well, I want a tree there, but I'm not going to show it to anybody in the reality. Well, the system maybe knows, but they put the tree underground, where nobody can see it or whatever. I don't think just the system knowing itself, conscious knowing, is going to be enough. The whole idea here is to see the way things happen inside the virtual reality, not outside the virtual reality. So I don't think so. But that's worth testing. That's the thing, where there's so many unknowns. For some reason, the physicists have not gotten really interested about, let's experiment around all these possibilities and see which ones work and which ones don't, to define the problem and see how it works. It's like there's this big open area that everybody's looking the other way instead of trying to solve the problems. It's almost like, well, here's our opinion and we don't really want to test it. But there is a lot of questions, that are still open. There's a whole lot of things. This experiment that we did do, which I'm going to put up pretty soon, you can put my slides back on, by the way, back there in the back. This thing that we did do had never been done before. Okay. There's a lot of things that have never been done before. And not because they can't be done, but just from a lack of interest. That's what happens when you think you know everything. You don't need to do the experiment. That's what happens when you're running your business on belief, because belief is never seen as belief inside the believer's head. Belief is always seen as a fact. So, lots of things that we could do to prove it. We don't really necessarily know what the answers are either, but we'd like to start peeling back the possibilities until we can finally isolate the answer. That's how science is done. But unfortunately, it takes people and money to do that. And you haven't been able to talk universities into doing it on their own. Anyway, this was the experiment that we tried to do, wanted to do, but couldn't do. Physicists said, just can't do that. We can't get which way data like you show it on your picture. It doesn't just come that way without us somehow interfering with the experiment. It seems that the concept of entanglement has grown to what one might call universal entanglement. Not limited to conservation laws. Entanglement used to be limited to conservation laws. If you have conservation of energy, you had an entangled particle, then the energy of the two entangled particles had to be the same as the energy of the original particle. Conservation of energy. You've had this particle in motion, and you get it creates two entangled particles, then the momentum of those two particles has to be the same as the original particle, conservation. Okay, so entanglement was limited just to conservation laws until, what, I don't know, 20 years ago or 30 years ago, when there was more and more pressure to figure out this non-local thing that was just annoying physicists to death. They couldn't explain it. That means their materialism had failed. So they were looking real hard to find ways to deal with that non-local stuff. That, you know, how did those electrons just rearrange themselves in a interference pattern? Okay, so the idea that everything's entangled with everything, I said before, that's almost as good as God does it. That makes everything entangled, so non-local, no problem. It's entangled. Entanglement is a non-local thing. You know, we got a spin-up electron here. Its twin is a million skillion miles away on the other side of the universe. We flip that one. That spin from an up to a down. That one flips from a down to an up. Conservation of angular momentum. The whole system has to conserve its angular momentum. So that makes sense. It's non-local. Okay, now we solved that non-local problem. Everything's entangled with everything else. But that's what it is I'm running into. But one problem that I didn't really expect that I ran into, that in some experiments, I don't have any other explanation of why they worked the way they did other than this universal entanglement. So it seems to work some places. Well, if you say something really general, it probably works everywhere. But it doesn't mean it's actually working. It means it appears to work. In other words, if you say, well, God does it. Well, how does that work? Why does it rain? Oh, well, God does it, you know. Why does it get hot in the summer? Why does the sun always rise in the east and set? No, God does it. If that's your answer to everything, then you're always right. And you got an answer for everything because you've got this one expansive answer that takes care of everything. Well, this everything's entangled with everything just takes care of the non-local problem. Non-local problem's done because everything's entangled with everything. But so far, the physicists have been right when they say this happens because the entangled information is in the, you know, is captured in the environment someplace. Well, they get the right answer. But I don't know whether they're getting the right answer just because their answer's so general it's always right, and there's something else going on we don't understand, or whether there's actually something to their answer. So, you know, maybe everything is entangled with everything. That's, you know, maybe a possibility, but it seems too easy to me. It's like God does it. It just seems too easy to me to be taken as a fundamental concept.
I have a question for you.
Uh-oh.
So I just want to talk about the Schrödinger cat, basically, but I want to show it with a beam splitter just to have a visual while we talk. This one. I just want to talk about this one. I just wanted to have a visual. So this is, I think, this is the core of the measurement problem. The core of the measurement problem is that this is the Schrödinger cat. I won't talk about the cat. We send a photon, a single photon, to a beam splitter. The photon has 50% chance of being transmitted, 50% chance of being reflected. But the thing, this is a superposition state. The photon, before we make an observation, could be in both, like the larger consciousness system has not computed what is the outcome. It's only when we look that it has to make a choice. Oh, let's do D1, for example, let's do D2. And this is the core of the measurement problem, because in all physicists, they don't know. They don't know why we see only one outcome when the math says there's multiple. So, and the thing that we need to understand is that when the photon, according to physicists, clicks, it doesn't click, but like if you follow the math, it could click here, it could click here, but then this is connected to a wire, connected to a computer, connected to a screen. So according to physicists, the two branches are equally probable. It goes into the wire, it goes to the screen, it appears on the right on the screen, and then lights go from the screen to my eye, and then it appears in my consciousness. D1 clicked, but like everything before was just like matter interacting, and it could have been just D1 or just D2. So it's only when I look that it collapsed. It collapsed the whole thing. So my question to you, Tom, is that do you think consciousness can affect the probabilities here? Let's say my intent, or can I get 49% instead of 51? Like, for example, if this one was connected to, let's say, electrocuting me, like if D1 clicks, I get a shock. And if D2 clicks, I don't know, it saved the lives of my mother. Can like we hope all together to really have D2 clicking instead of D1, and then increase the probability of getting D2 clicking? So that's my question for you, Tom.
Yeah, of course you can. That gets us back to the fact that the intent modifies future probability. Okay, so the way the rendering engine decides whether it goes this path or that path is that binary distribution. Goes into a binary distribution, says path 1, path 2, pulls one out. That's it. That's the path it takes. One particle, one path. So if you'd like it to take a particular path rather than the other, and you put your intent to it, you'd really want to sit this way other than that way, then you should get more going up one path than the other. And yes, that ought to be something that you can bias. You know, it's like biasing a random number generator. You have a random number generator that generates between 0 and 1, average ought to be 0.5. So you sit there and let it generate, and it's at 0.5. Well, it wanders a little bit, 0.499 and 0.5001, but it stays in there, and then you get an intention to go higher. And it starts going 0.5, 0.501, 0.51, 0.52, and it doesn't get much higher than 0.52. But then you have intention to go lower, and it gets down to 0.9, 0.93, that kind of thing. So it's not moving much, but the improbability of being able to do that with your mind, is high, as far as just looking at the physics goes. So yeah, that can be done.
So my suggestion is that, the interaction-free double slit, like I said, will cost like $10 million, and it will be super complicated to do. My suggestion is that if we can show this, it will make a crack in materialism as well, maybe as strong. So I don't know if Thomas from IONS is here, but in IONS with Dean Radin, they have done similar experiments, but I just feel that the number of participants, like the protocol, are complex because people need to come, they concentrate to affect random number generator, and they see some results, some impact, but it's weak, and there's not a lot of people doing the experiments. So I think this could be done at scale with like the game I presented. Like this is my point. Like Protocol Academy is, we could make a game that's fun, and we can then associate meaning to these two results, like losing life, destroying my character in the game, or like evolving my character. It's already more meaningful than just say, oh, try to get more ones or more zeros. So my point is that I think there's an opportunity here to show some result.
Yeah, but I have two questions then. This is going to be David and I having a conversation. I got two questions then. Okay, Dean's already done this. It hasn't changed the world. But the way to do this that is more dramatic is you break it into pieces. And you say, all right, now, today we're going to sit down and make the random number generator go higher. And it goes higher. And then you say, all right, that experiment's over. Let it go normalized to 0.5. Okay, now we're going to make it go higher. It goes higher. If you do that 10 times in a row, that's the same probability as flipping a coin 10 times and getting heads every time. So now you can look at that and say, well, it's not just that we made it go higher, but we can make it go higher when we want to. You see? And that, you make it go higher 100 times in a row, flipping a coin 100 times and getting heads every time. The probability starts getting astronomical. And that's the way to, to show that you're doing something that's 1 in 100,000, just luck. Obviously, something's going on. Yeah, you need to do it and repeat, so you're real clear with the process. Now we're going to do this and do it. Because if you do that and it goes the opposite way, well, you just debunked your own theory. Yeah, so you need good people who practice at that and get good at it, at moving data. Dean probably has a list of them. Oh, yeah.
Just on tech-wise, just to say, Elon Musk is working on Neuralink to do implants in the brain so you can control machines with your thought, basically. But if we can prove that this works and that intent allows to affect the probability of random number generators, this is a technology that allows to affect machines without implants. So I could just have the intention and then my phone make a phone call to whoever I want. So this is worth billions of dollars. Plus, it can show that the materialism is false or incomplete. So you're saying if there's investors who want to make $1 billion today, I think it's a good investment opportunity. I'll tell that to my investors, by the way.
I got a bit lost between. I understood that Tom showed an initial notion that he had on the experiment, how it should be. Then he explained why it could not be done. And then you explained something that we could probably do that's more complex and need more money. But I didn't understood at the end because something was really done and it was not Tom's initial option. And I am not lost what was really done. I know that something was done, but I don't know exactly what design was done. I'm sorry if I lost myself in it, but
no, you're just ahead of your time. That's my next slide, or the slide after my next slide.
I have a reason to be lost, so I'm happier now.
Yes, it seems like now that physicists have come up with 3 ways of dealing with non-local information. How do we deal with that? How do we get that back into materialism? One of them, like we just talking about, was everything's entangled with everything. But the first 2, one was many worlds. That was a way of getting by. All right. This non-local stuff is that we're jumping from world to world to world. That's what causes the other one was simulation, which you can do non-local things in simulations, but it's from the bottom up, because if you're a physicist, you're a determinist, and determinists have to go from the bottom up. It's for the particles, tiny subatomics to atomics to so on, and you build up the chain. And that's also impossible. Now, both of those, many worlds and a simulation from the bottoms up, that's not impossible as far as an idea goes, but it is, in my view, impossible as far as actually implementing. You can't implement quadrillions of physical realities. That's a lot of stuff to do. Every time an electron flips its spin, you have to spin off another whole universe. It's just impractical. Doesn't, you can think about it, but you can't actually do it. And the other thing is with the coming from the ground up with the particles, it's the same way. It's too hard. You can't build physical things out of a zillion calculations for all the subatomic particles and how they're built up and how they interact, and all that stuff is constantly in motion and moving, and the processing required is just too much and way too slow. It's just impossible. So those are the 3 ways, and I think those first 2 kind of just fail from common sense. The entanglement, everything with everything, that seems now to work occasionally around the edges, but like I say, maybe it's just because that will, by definition, work with everything, and it's getting the right answer, but for the wrong reason. So All right, then we move on. That says what we originally wanted to do. That is not right. That's what well, when we realized we couldn't do what we wanted to do, this is what we came up with. We were going to do this. And the reason we picked this one to do is because it was very simple to explain. And we thought the results would be easy to convey. And that is, this is the double slit. Now you see we have entangled particles. We've got polarizers. That's what these things represent. Horizontal, vertical, 45 degrees. We got all this set up. Which way data goes up, it hits this thing that's sensitive to polarization, and all the verticals go up there. The horizontals go this way, so we can measure the which way data. Because when a particle comes down here and goes through this slit, then its twin is also horizontally polarized, and it goes the bottom path here. And when it goes through that one and it's vertically polarized, it goes through the upper path, so we can say, depending on whether we get it B or B prime, we can say what slit it goes through. So it's pretty straightforward. And when we did that, we found that because of the polarizers, the data rate was terribly low. He was running it for days at a time, not getting enough data. It took a long, long time to get the data. And we fixed that by complicating it, actually. We put 45-degree polarizers in here, there, and some other place, and did this. This was my expert. My expert consultant came in, and he says, well, you need to get a higher data rate. So he changed a few things, which actually left the experiment the same, but made it a lot more complicated for us to tell you about. So it's really not worth it, because you would hear a bunch of techno-babble, double talk sounding stuff as we explained it. Well, this rotates it this much, and the other part rotates it a little bit more, and this does the other thing, and it just was very complicated then. But it worked. We got the answers that were expected. So that was what we intended to do. And then, simultaneously, at our second university, we duplicated the same experiment, but we did that in modular pieces so that it could be used, these modular pieces could be used to set up multiple experiments. And this was going to be the process by which we created this wonderful website that would attract attention to CUSAC by giving physics departments all over the world a chance to teach with tools where they could actually go in and turn a polarizer on or off, or do this, or move the slits further apart, or change the frequency of the laser. And they could do all these things and actually see the result on a screen right next to them. So that's kind of a first. It's not available anywhere else. So this was done then very modularly. And those pictures that David was showing you, they were showing you just pieces of an experiment. Well, if the particle goes the bottom route, and then he'd show you another picture if it went the top route. That was the modular design that we did. All right. Our goal was to create quantum bona fides, and we did that, I think, with this. Now, here's the last thing that I wanted to say, is that this was taken from David's, he showed you these earlier, so I took them from his paper. So what we have here is both of these together are really an experiment. He's broken it into two pieces so he can demonstrate how that works. Well, what the result of this experiment is that if you look at the D1 here and here, both together, you look at both of these D1s, you'll get what looks like a particle pattern. The physicists say, particle pattern. That's because this entanglement got entangled, with the world, and that preserved the which way data, and that's why we have a particle. All right? But what you find if you say, well, I just want to look at the particles that go through, say, this slit. If you just look at the particles, so you can do that. You can go up here at the timing that they hit and say, for the things that timed up here with D2, I just want to see the times that came through D1 that correspond to the times that what went through D2. So you can match particles that way. And if you look at this way, when it was minus 40, this was 45 degrees, you'll see the particles came through both slits, but it's at 45 degrees. But what you get is an interference pattern. See? That's the interference pattern I was looking for. I said, well, I don't believe in entanglement all over the world, so that's going to give me an interference pattern, and it didn't. But if you look inside that particle pattern, you find an interference pattern. Now, what does that mean? That means when the particles got to these slits, the rendering engine did a random draw from a probability distribution that looked like an interference pattern. From each slit produced an interference pattern. That's why you get this interference pattern, but that's only if you look at this side. When you look at this side where that's 45, then you get the opposite pattern. This pattern has a peak where that has dips and has a dip where that has a peak. So when you add those two patterns together, you do get something that looks like a particle pattern. So again, these two together make one experiment. So, and this also showed up with the Scully et al. They did the same thing when they looked at, I don't know if you remember that, but they had a detector 1 and a detector 2 that were the results of the erased data. And when you looked at those, you ended up with each individually, you ended up with a interference pattern. You looked at them both added together, and you got a particle pattern. Well, the particle pattern was explained by saying everything's entangled. But I'm saying, wait a minute. That's not a particle pattern. That's two interference patterns. Make something that look like a particle pattern. And look like and is are two really different things. I can say, look at that mannequin in the ladies' store window. That mannequin looks like a girl, but it's not a girl. It just looks like a girl. And even if that mannequin is dressed up with single hairs for the eyebrows and everything else that you can't tell, it's still not a girl. How do you know? Well, you have to dig deeper. You have to see what's inside. Well, when you dig deeper into this particle pattern, so-called, and see what's inside, you find what's inside is interference patterns. Weren't supposed to get those, but you do. But they make something that looks like a particle pattern. So I found that interesting. And there's other times when this occurs and the system says, oh, well, entanglement with the world caused this to have a particle pattern, but they don't have this ability to go in and pick out what's inside. You don't have that information. Then I'm thinking, well, are there really two interference patterns in there? Is that what's in there? You'd have to set up an experiment to see. But every experiment we've seen so far that allows you to look inside where the data's been erased, yes, if you add, like I say, erasure can always take place in two paths. And that's just a part of the symmetry of the experiment. You can always do it this way or that way. When you actually put a polarizer up there that's at 45 degrees, you get both. Horizontal polarization, whether it's this way with the arrow pointing that way or this way with the arrow pointing the opposite way, it passes. So you always get both. So you're always going to get these interference patterns that pi, 180 degrees out of phase with each other, and they're always going to sum to what looks like a particle pattern. So I'm thinking maybe there's another answer for that, and a little more research would maybe help if we can't find situations where we can test. But this is answered by the physicist as a particle pattern because of entanglement. don't buy it.
If entanglement turns out to be true, does that upend the whole MBT model of rendering?
No, it doesn't at all. It doesn't turn that whole thing around. I'm just trying to answer basic questions so we can figure out better how the world works. You know, it doesn't make the MBT thing different. It just means that my vision or my understanding of the way that the rendering engine is going to work was wrong. Okay, that's all. I mean, the larger conscious system is an aware system. It's conscious. It's got choices. It can do things this way or that way. It decided to give particles the attributes of waves, even though that's kind of a funny thing to do, right? So now particles act like waves. You know, every chunk of mass has a wavelength. You know, if you were thrown through a polarizer, you would be polarized. But big masses like us have really, really tiny wavelengths. So that's the last slide.